We have some nice, kind, and wonderful Epsom salt, bath salt here. And what we want to know what it means for this to pertain to demonism. You know? Matrix, Nexus, demonism, criminal, and just general stuff. You know, it was in my bathroom. I bought a big bag of it, and I made a battery out of it because we were interested in making a new kind of battery for solar panel systems that would enable us to use proficient batteries of Epsom salt and stainless steel, where actually we might be able to recover the product and recycle it, okay? A recyclable system where it would be cool and all. And not only that, we wanted it to be cheap, effective, and abundant. So, like, I decided abundancy was decent for Epsom salt, but although it has sulfur in it and magnesium, and the only thing is like, you know, it's not as abundant as you might think, I guess. It's there, it's not really all that abundant. So we asked ourselves, what else is abundant? Lithium. Lithium might be better, but the question is, what does this also do for healing, demonism, matrix, nexus, things like that? Spirits, demons. You ever read the old folklore that you take some rock salt, which is basically like Epsom salt, except they may actually add like maybe phosphorus or calcium to rock salt. It's kind of like this. We don't know what the real difference is in the form of like folklore, but I'm sure there is a difference. There's always some kind of difference. But like, what does Epsom salt do to spiritual demonism? Especially playing with it or whatever, adding water to it. What does it radiate? What does it emanate? What causes such a thing to affect people or things? This is sulfur, magnesium, and whatever else, I don't know. But it's a crystal powder, you know. Sexual, what is it? Sex bait, yeah. They tried to call it sex theory when I thought it was a crime. But it's for cleaning things, like maybe your feet. As long as you don't soak it in like a huge amount, the dosage has to be pretty minimal. You want to use it weekly, you know, and very amounts of pure water. But it has multiple purposes. It's actually a mineral. And generally, the magnesium part, though, it will poison the the crap right out of you. Okay, we're gonna leave that on there, but it will poison you. This stuff is in high doses. Like if you try to eat that right there, it is extremely poisonous. If you try to soak this amount through your skin, it is extremely poisonous. And it's like salt, like any other crystalline. High doses of any crystal or mineral or metal or something, it's poisonous. You don't do it. You don't do such a thing. Okay? If you do, you're crazy. So either way, what does it do to sit here in a box and radiate the potential radiation effects? Now, what we want to do, I'm going to get this device here and show what the radiation of magnetic energy and or ionic light does. Where are we? Mr. Energy Man? Mr. Energy Device. You little evil energy device, where'd you go? Mr. Energy Device? Hey. Here you are. Okay. People, we watch little kids conduct more offensive science experiments, so don't be too afraid. I'm 41 years old and I've been down the road a while. So like, here we go. Although it doesn't mean that some things don't happen, you don't know about them, or crimes weren't committed. So like we are assuming. Like, let's see what the radiation is on this. Does it show any radiation? Yeah. 70.7 to something, 0.8, 0.6, 0.88, 7, 9. So it concentrates. Let's move it around. It's buried in there. See what the inner radiation is. So down in the Epsom salt, radiation is reduced. Now let's go on top again. It's only on the surface that is an increase. Okay. So that should be good enough for information there. So it's not a volatilely reactive to light material. Okay? But although we are receiving a pretty high radiation reading up here, let's see it does upside down. .9, 0.7, 0.9, 0.7, 0.8, 0.9, 0.7. Now let's move it over this way. What's it do over here? Now let's move it away over here. Next to me. What's it do right here? It dropped all the way to 0. Now what is it right here? Jumps right back up whatever's right in front of me. Whatever's right in front of me went all the way up to 1.03. This is the Epsom salt. So let's move the Epsom salt out of the way. Now let's see what it does. There is something really radioactive right here upon this floor. Do not know what it is. Let's see what it does down here. Oh, it jumps way up. 1.11. Turn it up a little bit. 9975. Let's move it around a little bit. 84, 87, 1.04, 1.01, 0.03. The radiation must be greater in the PVC. Now let's move it up higher. It's radiation up here. Up above me. Oh, It's coming from the ceiling. Now it's greater than it ever has, 1.24. 0.01, 87, 18, 120, 161, 99, 104, 115, 117, 122, 136. So up here is a lot of radiation. Okay. That's about head level sitting on my couch. Okay, from the ground, emitting from the ground up. So that's a sign maybe that there's geometrical layer of energy from something. I don't see directly what it would be from that area. It could be anything. Maybe, you never know, Wi-Fi or anything, possibly. But you notice if I turn it this direction, what's it do when it points to me? .72, 0.8, 0.9, 0.7, 0.8, 0.76, 0.8, right in my belly. Okay. 0.65, 0.62, 0.72, 0.61, 0.59. Okay, not as exaggerated. Okay, now let's go back up here. Turn it upside down. 0.9, 1.14 of a certain level here from the glass. The window quite possibly may be amplifying energy. Yeah, I do believe that's what it is. Now, let's go from the same position here and see what it is. Let's turn it this way, toward the window. What's it do? Show 1.0399, 88, 82, 89, 73, 74. Let's turn it a little more. 72, 75, 86, 80. Reduces when I point it there. So what about down here? 91. Let's find it. What is it that's radiating? Above. Right here. High energy. 111-94101. Let's read this. One of 6, 88. This fan is saying that it has high energy. And it has now an electric field emanating from it, 250, 279, which is high, and low H field. And that's around the switch, even though it's turned off. Now it's 466, 600, 784, 880, 948. That, you know what that means? There's an electric field, an E field. Now it's also 119. That fan is not turned on. But is it the magnet here that does this? Let's take this magnet off here. Set it right there. Now let's test it without the magnet. Okay, no. It's the switch. 893, high micro 95, micro Tesla 998. It's about half harmful on the electric field effect. These electric fields can actually shock you, and they will pull energy all around you. They will cause an electric field all around you to increase in extreme amounts of, it says volts per meter. Just one of these fans, box fan, it's not even plugged in. Now if I move from the switch, say a foot away, the E field drops to 0. Okay, that means it's scattered quantum physically. But the micro Teslas are 0.88, 0.77, 8493. It's reading a different kind of radiation there. One, it's converted. That's what air does. It converts energy. So let's see how far it is. 3-4 inches. 5-3. So what it does is it takes that E field and converts it into, from an electric field, which is nuclear, and converts it into a light signal called radiation, or also magnetism. Okay. So that's not even all, but it's got an electric field attached to it. Okay. That means there's something, and what we know about electric is that anytime it's plugged into a power source, it doesn't have to be connected. In order to allow quantum energy to pass through anything that is potentially conductive and or the atmosphere, and it will radiate that way. So like, let's check this battery out here. What does this battery say? Okay. This lead acid battery, sealed lead acid battery that you can't take apart. Legally, you shouldn't. Okay. It's 60. It's one notch. And it's about there. Slowly increasing from the outside of the case. Very low micro Teslas. It just dropped off the E field. It went back down to 61. So the battery is also partially discharged. So if we want to look at the voltage, see what the voltage is. Now let's see what the voltage is. Currently the voltage, 10.20. It is not a dead battery. It's dead in terms of full charge. You can still run things off of it just because it's 10.2 volts, and that will run things. You don't actually have to use one of these batteries at full capacity. The only reason that they tell you that you do is in automotive shops for cars, because a car needs a full capacity charge in order to operate things. But little devices like this power adapter dongle, clocks, small LED lights, electric wires, small motors, you can run all that off a partially charged battery. You know what? It can actually last a lot longer, but however, it may sulfate if you don't charge it properly, they say. So like, it ain't going to affect it as much as you think. So you might get it charged up to say 12 volts if you need it that high, or 10 volts, 9 volts, something like that. You can let it vary. You just won't have as much amperage because the battery actually just holds the charge upon the terminals. It's just holding positive charge because the solution is still, and it's actually already conducted between the cells, if you will, it just holds the charge on each terminal, positive and negative. Okay, so it holds it there. The solution won't move until you discharge the two terminals. Then it will radiate and recycle. The positive will reduce and the negative will dissipate. Okay? And it will subtract positive, send the negative to the positive, positive to the negative into the solution, and reverse all of the chemical reactions. It's called a battery. Okay? So the field on those aren't too bad. You know, not extremely bad. You might want to do a chemical radiation test, but they're supposed to be sealed so that they can leak small amounts of gases, small gases. And when they do, it's about time to get rid of it. If it leaks enough gas, we've had this for a little while. So either way, other things that radiate. Now, let's check this out. We got a radiation tool here. We could make a better one if we really wanted to. This is kind of junky. Now let's check this sucker out. This is an LED. It radiates right up on it, a lot of microteslas. I mean, a pretty decent amount of energy. Okay. See it climbing up there? About 4.15 to 3. Okay. Now, let's check out this air conditioner unit. What does it radiate at? Check it out. Let's see. Here's the main power wire. Dude, that sucker is extreme. 10 microteslas. 11, 6.0. Dude, I hate to tell you, but honestly, that's a concentrated energy, and spreading it out, I can feel it. Dude, it's really messing even with gravity. You know, spiritually even, that's a high amount. But you know what? You don't see an electric. Oh, now there's the electric field on the main up to 14.85, 770 volts per meter. Dude, 15 microteslas, 726 volts per meter. That shit probably causes a lot of human interaction. And guess what? We know that it does. It is harmful as hell. You do not want to sleep next to one of these things. And guess what? As you see, this is my bedroom. I don't have a bed in here because I had to get rid of it. But I sleep right here. Guess what? It's right there. That is a bad idea. It needs to be moved. But legally, this is the best option. So, it's not righteous. So what else? You know, over here against this wall, we have air conditioners outside across the wall. It will also radiate you in a seriously hardcore way. Right here is more like where you would put the couch next to the window. Makes more sense to have it all right there. Okay, arranging things so that they work in even subatomic and atomic general physical theory, legally and criminally, that's exactly what you need to do. But general radiation, let's check out this light here. Let's see what we got here. Now this is a little, 10, 13 watt LED bulb. So what do we get? 0.24 microteslas, 0.48, 0.34, 0.44, 0.62. 0.26, 0.3. No electric field from the bulb top. 0.09. Dude, that is extremely weak. Like, my body is hotter than that. I produce more ionic energy, more electric energy than that does. However, if you go down here to the cord, okay, you go down to the cord here. What does it say? 0.88, 0.91, 0.73, 0.126. The cord that leads up to it is hotter than that. So the actual light coming out of it is being reduced in the form of radiation. So if you take a hot energy, reduce it to a low energy, somewhere there has to be radiation. And that's what happens. Anytime you use a hot energy, a large energy reduced to a small energy, has to be radiated in some way. Most people design their stuff to radiate that stuff slowly and accurately without catching things on fire, without actually being too resistive or not conductive enough. So, in general, here's a radiation. This is a piece of copper. Check it out. Piece of steel, sheet copper. Hell, this copper radiates more than that damn LED bulb. It's doing nothing at all but radiating the color of copper. Okay, constantly. More than the LED bulb. Why does that make sense? Here's some steel. What does it do? About like copper. About the same bit. Wood. Wood. Wood's radiating. Let's go up a little higher on the wood. Bah. Actually, it was a little higher than the copper and the steel. Oh, up to 0.974. Wood radiates more. Ain't that some shit? What about this plastic here? Plastic, what do you do? Plastic is not radiating at all. Say what? It's blue also. Ew. This thing does not read plastic radiation at all. Okay? But a can of WD-40. What does it radiate? No radiation, hardly, very little. 0.08, 0.15, 0.10, 0.3, 0.03. Very little, hardly none. Doesn't radiate very much. Probably lots of other things. Let's see what this sponge does. This will be interesting. Sponge. If you ever question what your sponge is, soybean sponge radiates, see if you you're hot or something. What do we do here? You radiate anything, sponge? Move around. Sponge does not give off E field or H field right there. 0. Now, we got this carbon filter for a filter machine. Let's see what it radiates. Does it radiate? No. This box of metal shit, what does it radiate? This box of metal junk, electronics and wires, see what it radiates. Electronics and stuff. Dude, it weakly radiates. Oh, even up to 0.51, 0.8, 0.9. Some of this stuff, 1.1, that stuff radiates. This is why metal is potentially dangerous in your body. Certain metals. Plastic, what does it do? It doesn't react very well. Now, okay. What was the radiation on that? Let's see. Let's move around this stance right here. Look at the radiation coming out of that. 1.74 to 0.2 microteslas coming out of my radar. 2.19 microteslas. That's more than anything little that I've measured. Okay. Even the battery, the lead acid battery doesn't radiate that much. That means that it has transistors 252. That's a radio. Okay. And it's not like the TV. The TV's even worse, a lot worse. This fan is extremely worse. It's really radiating, even though it's not running. Magnet didn't really produce that much. Magnet field. The window. Let's see what it radiates. What do you radiate, window? 0.3, 0.5, 0.6, 0.4, 0.56, 0.6, 0.72. Huh, my little radiator radiates more than you. You don't radiate much. Let's see what this fish oil radiates. This is a bottle of fish oil. Was it 0.7? It radiates more than the window, 0.8, 0.9. Okay. Witch hazel. What's witch hazel do? 0.8, 0.7, 0.82, 0.5. Aluminum pop can. 53, 7685, 7689, 77, 88. Not much. Not really all that much. That's pretty regular. That's kind of normal heat radiation. Hell, that thing radiates more heat. This big sheet of aluminum here. What's it do right on it? What do you radiate? It's not radiating at all. Okay. These supposedly unplugged light bulbs, what do they radiate? What do you radiate? Nothing. What do you radiate? Nothing. Okay. My jacket. Not radiating at all. Okay. This cook box. What do you radiate? You radiate a lot more. 0.73, 0.62. Could be because of the material. Okay, and the color is red. Okay, now what? What does this garbage radiate? Nothing. Laundry detergent. What does laundry detergent radiate? Anything? Laundry detergent isn't radiating. Okay, 34-minute video on radiation. Let's set this down. I'm burning up. I think they turned off the air conditioner permanently. Okay. Pizza pan. What does it radiate, pizza pan? Fork. A bag of sugar. What do you radiate? Go inside and see what it radiates. And it's a crystal, so it radiates. Radiates regular amount of radiation. Can of vegetables, what do you radiate? Extremely low, a little bit of radiation, 0.14, 0.3, 0.03, 0.19, okay. Microwave. What are you, oh my God. Holy hell, it's not running. It says 6.2478, counting. 81982. 84. About 8.4 was the max so far. Man, that sucker's really radiating, buddy. That means that every time you cook with a microwave, you break the materials down. When you do, it causes them to radiate for a while. 6.66, 7.2, goes all up to 8.4. Now this stove here, what does it do? Does it radiate? The coil on this stove is 0.5 next to a hot coffee pot. Might I add, 0.73, 0.85, 0.96. Not really all that radiation. What's this diamond skillet radiate? Hardly nothing. Mazola corn oil, what does it radiate? 0.10493, 123, 114. Corn oil seems to be pretty radio. What's this other canola vegetable oil radiate? About the same. What's this box of shit here radiate? Box of food. A little less. And the corn oil about 8. Oh, 1.74. Oh, now it's really 2.14. Dude, that shit is radioactive. That's a high amount of radiation. That is really radiating, buddy. Oh, God. I don't want to eat that. Let's see what this coffee pot radiates. Hot coffee pot. .48, 0.63, 0.5, 0.78. Not really nothing, man. Glass. Really don't radiate. Let's coffee. Let's see what coffee radiates. And we gotta open it up. What does it coffee radiate? .28, 0.19, 0.3, 0.17, 0.11. I don't hardly radiate at all. The water in this filter thing here, what's it radiate? You radiate much? 0.4, 0.13, 0.07, hardly radiating. Okay. This thing is table salt. What's it radiate? Nothing. Okay. Onion powder chips. Nothing. Okay. Bottle of protein powder from the plastic outside. Nothing. We ain't got to measure the inside. Let's see what these Oreo cookies are. Let's see what Oreo cookies measure. What do you measure, Oreo cookie? You're black. You don't measure anything. Okay. This thing of water down here. What does it measure? Ooh, this thing of water, 4.19, 4.16, 5 point. The Teslas are really extremely radioactive in this thing of water. And then it reduces and falls off. This could be because it's transmitting heat. We don't know. But now it's dropped down to extremely low. What the hell? I do not know. It went from high to extremely low. Let's do the refrigerator. What does it radiate? From the front, hardly nothing. What about inside? 0.46, 0.68, 0.8, 0.83, 1.01. Not extreme amount. Peroxide, what does it radiate? Plastic. Nothing, I'm not going to measure that. What does this electric shaver radiate? Nothing. What about this? Nothing. What about this hat? Nothing. What about the sink? Hardly nothing. Sulfur soap. Sulfur soap is 1.36, pretty, 1.3, 1.19, about 1.3 or 4. Pretty high radiation. Stainless steel stock pot pan. That's similar, but a couple points down. About the same as sulfur soap. Okay. What does a mirror do? What does a mirror do? Very little radiation on a mirror. A toilet. Where does a toilet radiate? From near it. Now let's point it at the water.